Euler diagrams is the topic of the 12th theory session of the problem-solving test course. We will learn how to calculate intersections and unions of various sets and also find out why this knowledge is important for the McKinsey PST. We will kick off with exploring a hypothetical class of a hypothetical business school. You might want to pause the video now, as always, and try to tackle the question on your own. Based on the information above, how many students in the class of 2020 at the Nikola Business School have both consulting and industry experience? From the text, we know that the class consists of 100 students. 75 of them have consulting background and 50 have industry background. And 20 students have neither consulting nor industry background. And the question is, how many of the students have both consulting and industry background? The best way to tackle this question is by using a Euler diagram. Let's draw it here. The total number of students is 100. Those with consulting background, 75 people. Those with industry background, 50 people. Those without consulting and industry background, I write it here, 20 people. Then the union of these sets, people who have either consulting or industry background, is 80 people. And we want to find the number of people who have both consulting and industry background. This is this subset here. How do we do that? We need to find this segment first, and then we'll be able to find the answer, the intersection of the sets, by subtracting the number of people with consulting background only, this part here, from the total number of people with consulting background. So the number of people with consulting background only, I would call it A and not B, where this is A and this is B, is 80 minus 50, these guys here, equals 30. And then the number of people with consulting and industry background is 75 minus this part here, A and not B, 30 equals 45. And this is our answer, C. Let us consider the solution of this problem more slowly. Euler Venn diagram is a way of visualizing sets, their unions and intersections. This visualization will help us establish relations among sets and subsets and move from known sizes of sets to the unknown. In the example above, we start with the general set, the whole class, 100 students. We call it S. Then we draw a subset A, all X consultants, which is 75 students. A should be within S because it's a subset of S. Then draw a subset B, all 50 students from the industry. Notice that A and B must intersect because there might be students with both consulting and industry experience. Also, A and B lie within S. At the next step, consider the set within S but outside of A and B. It is called complementary to the set A or B. We know that its size is 20 people. Now we are ready to compute some unknown sizes of the sets. Set A or B, students with consulting or industry background, or both. Its size is equal to S minus the size of its complement, namely 100 minus 20 equals 80 people. The set A and not B has the set B as a complement for the set A or B, whose size is 80. Therefore, the size of A and not B is 80 minus 50, the size of B, or 30 people. 30 people have consulting background but not industry background. Symmetrically, B and not A has the size of 80 minus 75, the size of A, or 5 people. 5 people have industry background but not consulting background. Okay, now we are ready to find the number of people who have both consulting and industry background. A and B is a complementary set for B and not A, and a complementary set for A and not B. So its size is 50 minus 5, or equivalently 75 minus 30, or 80 minus 30 minus 5, which is 45 people. This is the desired result. The Euler diagram in this example helped us understand the relations among sets and figure out how to mix and match them to get where we need. This is what the diagram is used for. There is no simple one-size-fits-all algorithm for solving set questions, as we'll see in the next example. We have to come up with a solution using the diagrams as visualization. However, a very generic algorithm might look as follows. Draw sets as rectangles and circles. Pay attention to their intersections. Then assign known values to sets. And then calculate the unknowns one by means of operations with complements, unions, and intersections. The connections between pictures and corresponding math operations are shown on the right. Here's a more complicated example. Pause the video now and try to solve the question on your own, and after that continue watching. If 3 out of 38 associates work long hours and do not have time for sports at all, how many associates at zero-sum consulting are active in all 3 mentioned sports activities? From the text above, we learned that there are 38 associates. 16 of them play basketball, 18 play soccer, and 17 are surfers. And then several consultants are active in exactly 2 sports activities. 4 in surfing and basketball, 3 in soccer and basketball, and then 5 in surfing and soccer. Let's draw the Euler diagram and try to tackle the question using it. The total number of people is 38. And then there are 3 intersecting sets. B, people who play basketball. Soccer, people who play soccer. And then surfing, people who do surfing. Then there are 16 people here, 18 people here, and 17 people here. And we also know that the number of people in this segment, basketball and surfing only, is 4. The number of people in basketball and soccer only is 3. And then the number of people in soccer and surfing here is 5. And we need to find the size of this small set here. We also know that there are 3 people who don't do sports at all. They're here. So the first obvious step would be to calculate the union of these 3 sets. Because 3 is the size of the complement to this set we're computing. Now we need to calculate the intersection of these 3 sets. And this would be possible if we express the size of basketball or soccer or surfing in different terms. Because equivalently we can write 16 plus 18 plus 17, which is the sum of these 3 sets. But then we also had some double counting because we counted this segment twice, this segment twice, this segment twice, and then this segment here 3 times. So we need to subtract 4, we need to subtract 3, we need to subtract 5, and we need to subtract x, the size of our desired set, 2 times. Because in this calculation here, it was included 3 times, and we only need 1. So there are 2 people who are active in all the 3 sports activities. And this is our answer, A. Let us synthesize what we have learned today. Euler Venn diagrams are a great tool for visualizing relations among sets, which is helpful in solving questions about sets. We need to draw all sets, pay attention to complements, unions, and intersections. Then we write down the sizes we know. Then we start computing the sizes we do not know, and visualization helps us decide how to do that. After some struggle, we arrive at the answer. That's it for today. If you have any questions, I'll be happy to read and answer them in the comments below. Thanks for your time, and until next session.